So today I'm going to start with determinants. Now let's go through the introduction of this determinant. So why we are studying this chapter? So it is basically used to check whether the solutions of the system of linear equation is unique, infinite, or there is no solution at all. So first thing we should know, what do you mean by solution of linear equation? Now solution of linear equation means, suppose if I have a linear equation like 2x plus 5y is equal to 9. Now solution of this linear equation basically means the value of x and y which satisfies this equation is known as the solution of this linear equation, right? So in this chapter we'll try to learn how to solve three linear equations with three variables. Okay, so like this: 2x plus 7y plus 9z is equal to 1. So we'll learn to find three equations with three variables, and we need to find the values of x, y and z. So if those three equations has only one solution, so only one values of x, y, z, then we can say that unique solution. If they have infinite solutions, or they will have no solutions at all, right? Now the next one is, it is used to find the area of a triangle, which we already know that's half into base into height. But in here we'll learn a different method. Now it is also used to find the inverse of a square matrix. We already learned to find inverse of a square matrix in our previous chapter, that is matrix by elementary row operations or column operations. Clear? So let's move on to the next slide. Now it says determinant. So what is determinant actually? So determinant of a square matrix. Now here the fact square matrix is mentioned because determinant is only possible for a square matrix. It is not possible for any rectangular matrices. Am I clear? So to every matrix A is equal to, you see this is how we denote matrix of order n. So n basic, why n? Why not n cross n? Because a square matrix we can write it as only one number, that is n, because the number of rows and number of columns are same. We can associate a number. So what does it mean? Every matrix, for every matrix we can associate, we can give a number. So determinant actually does what? It gives a number to every matrix. Okay, so it is denoted by this sign. Now don't confuse it with mod. It looks like same as mod, but it is read as determinant of A. Determinant of A, or this delta sign, right? Now if A is equal to determinant of A, B, C, D, this is to order 2, then determinant of A is written as like this, mod sign is equal to A, B, C, D. Clear? And you see the same thing, this sign, modulus like modulus. Now this point I already told you that is only possible for square matrices, and this thing is read as determinant of A, not modulus of A. Okay, let's move on to the next slide. Now it says we need to find how we find the determinant of a matrix. Now determinant of a matrix of order 1. So order 1 means what? The number of rows is 1, number of columns is 1. Now how to find the determinant of it? The determinant of this matrix, suppose this is a matrix and it's A, the element is A of order 1, then the determinant is given by just the matrix itself, just the element itself, that is A. Clear? Suppose we have a matrix like this, the element is 5, so the determinant of A is 5. Understood? Now if I have a matrix of order 2, so how to find the determinant of a matrix whose order is 2? So let's find it. So determinant of A is equal to this, is equal to, first thing I will write the matrix in this form, A11, A12, A21, A22, and the determinant sign. That is equal to, what do you see in here? A11, A12. First I will multiply these two, A11, A12, then minus sign. I will write minus sign. Then what I will do is, I will multiply this side, A12, A21. So first I will go in this direction, then minus sign, then I will go in this direction. Am I clear? Okay. So an example is given in here. If A is equal to 4, 2, 5, 3, then determinant of A is, first I will go this direction. So 4 into 3, that is 12. Then minus sign, 2 into 5, that is 10. So 12 minus 10 is 2. Okay. So that's how we find determinant of a matrix which is order 2. Now let's move on to the next slide. Now the most important part. Determinant of a matrix of order 3, where there are basically 6 ways of expanding a determinant of order 3 corresponding to each of the 3 rows and 3 columns. So in an order 3 matrix there are 3 rows and 3 columns, and in order to find determinant we can expand in any one of those 3 rows or 3 columns. So basically there are 6 ways. Okay, so first thing today we're going to learn is expanding along R1. R1 means what? We are going to expand, we will learn how to expand along R1, this row 1. How many elements are there in R1? There are 3 elements, A11, A12, A13. So those elements will play an important role to expand a matrix. Okay, so first thing, determinant of A is equal to this. Now you listen very carefully. What it says is that is equal to minus of A to the power 1 plus 1 into A11. You see, why am I writing A11? Because it is the first element of row 1. Now you see minus 1 to the power 1 plus 1. Why 1 plus 1? Because the row and column is 1 1, that's why it's 1 plus 1. Okay, now the next thing is again determinant sign, and we see a order 2 matrix, determinant of an order 2 matrix. Now how did we get this one? Now look at here, I picked A11. Okay, here I picked A11. Then what I do, I draw a vertical line, then I draw a horizontal line. Okay, now cutting all those elements which the line cuts, whatever element remains, I find the determinant of them. You see A22, A23, A32, A33. In this form only, A22, A23, A32, A33. Okay, so for this first element, I found this value. Okay, now I have to add with that. Then for the next element, the row 1 is not complete. Now the next element is what? A12. So what I will write, minus 1 to the power 1 plus 2, A12. Okay, now after picking A12, I will draw a vertical line, draw a horizontal line. What remains? A21, A23, A21, A23, A31, A33, A31, A33. Understood? The same thing? Clear? Now after finishing this one, we move on to our last number, that is A13. So what it will be, minus 1 to the power 1 plus 3 into A13. Then again the same thing what I will do, after picking A13, I will draw a vertical line, draw a horizontal line. What elements remain? A21, A22, A31, A32. Clear? So that's it. This is what we got. So this is the way how we expand order 3 matrix along row 1. Now we will have to simplify. First thing, minus 1 to the power 1 plus 1. It's what? Plus 1. A11 into, you see, we already learned how to find the determinant of an order 2 matrix. So we'll multiply these two, then minus of multiply these two. You see, A22, A33 minus A23, A32, right? Like this way, we'll go along the way. Understood? Now minus 1 to the power 1 plus 2. 1 plus 2 is an odd number. So minus 1 whole cube is minus. A12, again multiply these two, then minus this 2. Then minus 1 to the power 1 plus 3. 1 plus 3 is 4. Minus 1 to the power 4 is plus 1. So plus A13, then multiply these two, minus multiply these two. Okay, so this is how we expand a matrix along row 1. Okay, now for easier calculation, the determinant must be expanded along that row or column which contains maximum number of zeros. Now why they are telling us that, why do we expand a determinant along a row or column which has maximum number of zeros? The reason is that, suppose we have A12 as 0. Suppose A13 is 0. Now if I expand along row 1, what happens is that, so A12 is 0, A13 is 0. Now if they are 0, then I don't need to write them, because they are 0. 0 multiplied with 9, so I don't need to write them. So if I don't need to write them, then I don't need to write this. So the calculation, what? It becomes so easy. So we just need to find this value. So we just need to find the value for A11. That is the first element. I don't need to find the other two elements. Why? Because we already know they are 0. Understood? Clear? So what was the reason to expand along the row or column which has the maximum number of zeros? Understood? Okay. So whenever I see 0, I don't have to find the determinant for, I don't have to find this thing for that element. Okay, now let's move on to the second point. What it says: while expanding, instead of multiplying -1 to the power I plus j, so they are talking about this one. Instead of multiplying this one, so what we can do is we can multiply +1 or -1 accordingly I plus j is even or not. Okay, so they are telling us that we don't have to multiply this one. A11 1 plus 1, we don't have to multiply. Why? The reason is that if I see A11, if I add these two, 1 plus 1 is 2, that is an even number, so -1 to the even number is plus, so I will give plus. Now if I see A23, if I say A23, 2 plus 3 is what? 5. 5 is an odd number, then I will use -1. If I see A33, 3 plus 3 is 6, that's an even number, so I will, so it will be plus. Okay, so I can or I don't want to write that thing for easier to, what should I say, to save time. Okay, clear? Now let's move on to the next slide. Now we have determinant of a matrix of order 3 which is expanding along column 1. Now we will be expanding along column 1. Now these three are the elements which we are more concerned about. No more these elements. Okay, so first thing is same as before, -1 to the power 1 plus 1. You see A11, 1 plus 1 is what should I say, even. You put a plus sign, it's easy. Now again the same thing, A11 vertical line, horizontal line. You see the elements in here, you see it in here, right? The second one, you see it won't be A12, it will be A21 because we are expanding along column 1. That's very, very important. You should have to realize that thing. So A21, 2 plus 1 is what? Odd number. So it will be negative. That's why it's negative. Understood? So -1 to the power 2 plus 1, A21. Now cut this one, this one. So what remains? A12, A13, A32, A33. A12, A13, A32, A33. Clear? Then plus -1 to the power, the last one, A31. That is 3 plus 1, that is even, so that's why here it's plus sign. Okay, now A31, now you cut, so what I get, this one cut, A12, A13, A22, A23, A12, A13, A22, A23. Clear? So this is how we expand along column 1. Okay, now you see here, let's simplify. This one becomes 1, A11, again the same thing, or how we expand. Multiply these two, minus of multiply these two, then this one will be minus sign. So like this we go on, right? So now we have an example in here. So we have 240136089. We have to expand along R1. Okay, so determinant of A is given by -1. So we are expanding along R1, or else we can expand along C1 also. Clear? Because it has same number of zeros. So -1 to the power 1 plus 1, the first element, that it will be 2. Then the determinant, it will be 3689. 3689. Okay, now the next element is what? Here it will be row 1 column 2, 1 plus 2. Sorry, here it's written 2 plus 1, but it is wrong. It will be 1 plus 2. Why 1 plus 2? Because row is 1 and column is 2. 1 plus 2 multiplied by 4. The 4 is the element. Now cut this one. What remains? 1609. 1609. Okay. Now the next one, plus -1 to the power. Again here it will be 1 plus 3. Actually what happened is that I copied from here to here. That's why I didn't change this one. I'm very sorry. So it will be 1 plus 3. Right? Multiplied by, you see, the last element is what? 0, right? So I just written in here to make you understand, but I don't have to write because it's 0, so forget about them. Okay, clear? So now after doing all this, so what we get, we move on to the next step. So what do we have? This one is plus, so 2, 3 9s are 27, minus 4 8s are 48. Then this one is minus, so minus sign, 4, 1 9s are 9, minus 6 into 0 is 0, and this one is 0. Okay, so now after simplifying, this one you get minus 42, this one you get minus 36. After adding, you get minus 78. Clear? So that's how we do this one. Okay.